Hello everyone, welcome back. Today we shall look at the last question of May-June 2023 for that maths paper 1 variant 1. And this last question is a vector question. The question is a plane has equation. So the equation of the plane is R equal, let me write it in vector form, in column form. There is no I, there is J minus 4 and there is K minus 3 plus lambda, a scalar constant. I is 1, J is minus 1 and K is 1 from the equation, plus another direction mu 1 1 minus 1. So you are asked to obtain the equation of the plane. Now alternatively, let me just we can write this. The directions are, let me call one direction A. The directions are, let's say 1 minus 1 1. The other direction with mu is 1 1 1. The equation passes through this point. It passes through this point. So the direct is in the direction of lambda and direction of mu. Now, the first thing you should do is to find the normal. Since we are giving direction, to find the normal is multiplication, cross multiplication of the two directions. Cross multiplication of two directions to get the normal. How do you get that? By using the determinant. I, J, K. The first one, 1 minus 1, 1, and 1, 1 minus 1. Don't forget, here is plus, here is minus, here is plus. So since we are using determinant, so the first one will be plus I. When you bring it out, plus I, that will be when you bring plus I out, so in that case you're going to have minus 1 1 minus 1 1 1 and minus 1. The next one is minus J. Then when you bring it out, if you understand your determinant, you're going to have 1 1 1 minus 1. At this point I expect you to understand determinant. So that was matrix and determinant, number the third or fourth topic in the syllabus. You should be able to understand it by now. And the last one, 1 1 minus 1 1. At the end of the day, our normal will be minus 1 times 1 is 1. 1 minus 1 is 0. Here will be 0I. There's nothing here. Minus 1 times 1 minus 1 times 1. Minus 1 times 1 is that give minus 1. Minus 1 times 1 1. This one give us minus, or what does it give us? Let me check it. Minus 1, that's minus 2I multiplied by minus j, so we are going to have plus 2j. And the last one, 1 times 1 1 minus it's going to give us 2k. So the normal for this direction is 2j plus 2k. That's the normal. Now, what's the equation of a plane? The equation of a plane is r dot n equal to a dot n. R is the position, x, y, z. N is the normal. The normal we obtain here is 0, 2, 2 equal to A. A is where the vector passes through, which is this one. That will be 0, minus 4, minus 3. N, as you all know, is 0, 2, 2. So at the end of the day, let's open the bracket. X times 0 is 0. 2 times y is 2y plus 2z. So equal to this is 0 minus 8 minus 6. At the end of the day, we have 2y plus 2z equal to minus 14. Divide through by 2. we have y plus z equal to minus 7. This is the equation of the plane. Is represented as plane 1. That's it. Let's move to the next one. Let's move to the next question. Question B. Question B. Okay. Now question B. We have a plane, the second plane. We have a second plane. So okay, let me check the, the space for us. Okay, the second plane, plane 2, is giving us as you can see, plane 2 is, let me write it here. Plane 2 is giving us r dot. R is position, x, y, z dot. What's the normal here? The normal inside this vector is minus 5, 3, 5 is equal to 4. Let me find the equation of the plane 2 first. So when you open the bracket, you're going to have minus 5 times x minus 5x plus 3y plus 5z equal to 4. When you multiply 2 by minus, we're going to have 5x minus 3y minus 5z equal to minus 4. This is the equation of plane 2. This is the equation of plane 2. And they said find a vector equation of the line of intersection of plane 1 and plane 2. This plane 2, remember, don't forget, plane 1 is y plus z equal to minus 7. This is plane 1. Now we are asked to find the line of intersection, vector equation of the line of intersection between the two planes. Don't forget there are some rules we have for when two planes intersect. Listen to the statement I'm trying to, okay. When two planes intersect, the line of intersection is a line. The line of intersection is a line that is parallel to both of the plane. The line of intersection is a line that is parallel to the what? To both of the plane. The line of intersection is parallel to both of the planes, which means that the line of intersection is also perpendicular to both of the normal. The key. The point at which these two planes intersect is perpendicular to both the normal of the plane. So which means you're going to have a direction. Because they intersect, there's going to be the direction of the line of intersection. Let's find the direction. So in this case, to find the direction between two planes, the direction will be cross product of the normal. So the direction of the two planes, let's do it. Then we have I, J, K. The normal of the two planes is 5 minus 3 minus 5. The other plane, this one, has no I, but the other one is 1, 1. So plus, minus, plus. Let's find the direction. Let's find the direction of the plane. So as we did earlier, plus I, this will be minus 3, 1, minus 3, 1. We have minus 5, 1, minus J. This one will be 5, 0. Okay, here with 5, 0, 5, 0, minus 5, 1. And the last one plus K, that will be 5 minus 3, 0, 1. So this one will give us, so the direction, the evaluation of the first one will give us 2I. If you use determinant, The other one will give us minus 5j and give us plus 5p. This is the direction. This is the direction of the two plane. Now, but we have to find the point of intersection. Now we have the direction. So the point of intersection will be calculated like this. So already we have the point. We have the direction. So let's find the point at which the line intersects. To get the point, choose any of the plane. Let me put z to be 0. You can use any. You can put any of the variable to be 0. If you put z to be 0, what do you have? We have 5x minus 3y. I'm using plane 2. Z is now 0 equal to minus 4. Since z is 0, we have 5x minus 3y. If z is 0, y is minus 7. If z is 0, so y is minus 7 equal to minus 4. 5x plus 21 equal to minus 4. At the end of the day, 5x is minus 25. X is equal to minus 5. So the point of intersection will be x is x is minus 5, y is minus 7, y is minus z is 0. In the direction of, let me use any, you can use any, they've used lambda, they've used mu, let me use t, in the direction of 2, minus 5 and plus 5. This is the point of intersection of the plane in that direction. Now, question C. Question C, it said a line passes through point A with position vector a minus 7. Now there's a line that passes through point A with the position vector. This is the position vector and it's parallel to this, where A and B are positive constant. So given that the perpendicular distance from A, this is the line, the line passes to point A, line L passes to point A, this is point A, line L passes to point A and parallel to this, where A and B are constant. Given that the perpendicular distance from A to plane 1 is root 2, find the value of A. Now, okay, in this case, my point A, let me put my point A to be Q. Let me put my point A to be, no, let me put it as P. My point A to be P. This is my point A. Now, anyway, we are talking about plane 1. Anyway, they said this question is about shortest distance between a line and a plane. We have a line. They said, but they gave us given the perpendicular distance between point A and plane 1 is root 2. The formula for the shortest distance between a line and a plane, the formula is PQ scalar dot n all over modulus of n. That's the formula between, this is the shortest distance or perpendicular distance between a line and a plane, where P, so P is the point where the line passes to. In this case, P is point A, which is A, and A minus 7. What's our Q? Q is any point on the plane. Q is any point on the plane they are talking about. Any point on the plane. And the plane, any point on the plane. And the plane is y plus z equal to minus 7, plane 1. So already, so just let's get our Q. To get our q, just put any variable to be 0. Since earlier, the previous question I put z to be 0, let me continue with. So if z is 0, y is minus what? 7. There is no x in this plane anyway. So in this case, q will be x is 0, y is minus 7. You have put z to 0. There is no x in this plane before, so x is 0. So let me use the formula by finding pq. What's pq? I need to make use of the space there. Pq is OQ minus OP. What's OQ? OQ is point Q, 0, minus 7, 0, minus OP. OP is point P, that's A, minus 7. So the dot, so I'm subtracting them. So this one will give us 0 minus A, that's minus A. 0 minus A will give me minus A. Minus 7 minus A will give me minus 7 minus A. 0 minus minus A will give us probably minus A plus 7. That's 7 minus A. This is PQ. The formula is PQ dot N. What's PQ dot N? Let's do it. PQ dot N. So PQ dot N is, what's our PQ? Our PQ is minus A minus 7 minus A, 7 minus A dot N, the normal of the plane. The plane is y plus z, so the normal is 0, 1, 1. If you note that, the normal is 0, 1, 1. So therefore, PQ dot N will give us minus A times 0. That's okay. Let me just put it in the formula straight. Absolute PQ dot N is PQ dot N minus A times 0. That's 0. Minus 7 minus A times 1. That's minus 7 minus A. 7 minus A times 1. That's plus 7 minus A. All over modulus of N. What's modulus of N? N is 0, 1, 1. The modulus will be square root of 2. Remember that the shortest distance is equal to square root of 2. The shortest distance is equal to square root of 2. So from here, minus 7 cancel plus 7. What do you have here? Minus 2a over root 2. Remember that we have this symbol equal to root 2. This symbol will make it positive. So this one will give us 2a over root 2 equal to root 2. So when you cross multiply, 2a is equal to 2. The value of a is 1. I hope you can understand the step and follow the way I did it. So that's it. The key to this question is the formula. Shortest distance between a line and a plane. Let's move to the next question. The next question, D question. Now D question, it said given that the obtuse angle between the line L and the plane 1. Okay, let me write the line L, the equation of line L. The equation of line L is when you check the question, line L in the question, I think is given as 1. The first I is 1 minus B, J is B, and K is B. Line L, that's line L. It said line L and plane 1. Of course, you know plane with plane. Plane 1 is y plus z equal to 7. And the normal of plane 1, there is no x, 0, y is 1, z is 1. The normal is this. This question is about line and plane. Angle between line and plane, the formula is cos alpha equal to direction of the line dot normal of the plane all over modulus of direction times modulus of normal. Now since it's an obtuse angle, so the final alpha is always, the final angle is always 90 minus alpha. In this case, they're giving us the final angle, which is 3 over 4 pi. You have to subtract it. 90 is pi over 2. The final angle alpha is 3 over 4 pi. When you subtract this, I think you're going to have pi over 4. 4 pi minus 3 pi, that's pi. Okay. The LCM of 2 and 4 is 2 here 1 is 2 is 4. 2 pi 4 into 2 pi 4 and 4 1. Let me find the LCM between, so pi over 2 minus 3 pi over 4 will give us minus pi over 4. So now d dot n, d is the direction of the line, so let's find d dot n. D dot n, d is 1 minus b, b dot n, n is 0 1 1, so d dot n will give us 1 minus b times 0 is 0 plus b, d dot n give us 2b. Modulus of d, of course, you know, is going to give us square root of 1 minus b square plus b square plus b square. Square root of n is going to give us 0 square plus 1 square plus 1 square. So let's substitute these parameters in the formula. Cos alpha is minus pi over 4 equal to d dot n. D dot n give us 2b over modulus of individual. This one will give us 1 minus b square plus 2b square dot n give us square root of 2. Cos of pi over 4 will give us 1 over root 2. Cos minus theta is cos theta. So cos of minus pi over 4 will give 1 over root 2 equal to 2b over square root of 1 minus b square plus 2b square dot root 2. So let's cross multiply. When we cross multiply, we have root 2 dot times 2b equal to 1 times this, 1 minus b all square plus 2b square times root 2. Root 2 cancel root 2. So what do you have here? 2b equal to 1 minus b all square plus 2b square. Square root. Let me check my space. I still have space. Oh, nice one. There's additional space. So from here, let's square both sides. Let's square both sides. So when you square both sides, what do you have here? We have 2b all square equal to 1 minus b all square plus 2b square. This one will give us 4b square. Collect the like 10 minus 2b square equal to, when you expand this, it's going to give us this. 4b square minus 2b square, that's 2b square. This one goes and meet them. That's minus b square equal to 1 minus 2b. At the end of the day, we have b square plus 2b minus 1 equal to 0. That's turned to a quadratic equation. So if you use the formula for quadratic equation, minus b plus or minus square root of b squared minus 4ac over 2a. Put this in your calculator. You're going to have b to be minus 2 plus or minus square root of 8 all over 2. So b will now be minus 2 plus or minus square root of 8 is 2 all over 2. So b will be minus 1 plus or minus plus or minus root 2. And there's a condition in the question. The question said, um, the question said, um, the question said find the exact value of b, of which b will be positive. So at the end of the day, the value of b will be -1 plus root 2. That's the answer. I hope you got it right. So I'll see you next class. Subscribe and share. Thank you.